this particular series of tutorials, we are going to discuss discrete Fourier transform, how to calculate it for 4.2.8. So first of all, the discrete Fourier transform, it can be calculated by using equation x of k is equal to summation n star from 0 to n minus 1 x of n w raised to n w raised to n k divided by n, where k star from 0 1 2 raised to n up to n minus 1, and where w raised to n k base n is e raised to minus j 2 pi n k divided by n. So this is a formula for calculation of discrete Fourier transform, where x of n is input and output will be x of k. Output will be x of k. Now, an inverse discrete Fourier transform, it is calculated as x of n is equal to 1 upon n summation start from k is equal to 0 to n minus 1 x of k w n raised to minus nk, where n start from 0 1 to n minus 1. So this formula or in general formula for n point DFT, this is used for n or n point DFT, n point DFT, n point DFT. Now if suppose we have taken n is equal to 2, means for 2 point DFT, the formula we have written x of k is equal to summation n star from 0 to n minus 1 x of n w raised to nk basis n. Put the value of n is equal to 4, so that this formula will become x of k is equal to summation start from n is equal to 0 to n minus 1 x of n w 2 raised to nk. So now we know that k we have to put 0 1 2 up to n minus 1. So n means 2, so k value is 0 and 1 for 2 point. K value is 0 and 1, so that we have x of 0. So 0 you have to put x of 0, n stands for 0 to 2 minus 1 x of n w raised to this k value. This is the k value we have placed, so that after putting it, it will become x of 0 w2 raised to 0 plus x of 1 w2 raised to 0, means any raised to 0 w value is, it is e raised to minus j 2 pi nk divided by capital N. So 2 raised to 0, it means e raised to minus j 2 pi into 0 divided by 2, so that it is equal to e raised to 0, answer is 1. So it is x of 0 plus x of 1, so second is 0. Now put k is equal to 1, so it is 1, actually 1. So x of 1 is equal to summation start from n is 0 to minus 1 x of n w raised to n into 1, k value is 1. So that after putting it, it will become w2 raised to 0, w2 raised to 1. So if you calculate w2 raised to 1, it is e raised to minus j 2 pi, n value is equal to 1 into 1 1, so divided by 2, so it is e raised to minus j, that is equal to e raised to minus j, it is minus 1. So it is calculated like this: cos of, it is j pi, cos of pi minus j sine of pi, so it becomes cos pi is minus 1, this is 0, so answer is minus 1. Hence for 2 point, we can write in matrix form as x of 0, x of 1 is equal to w2 raised to 0, w2 raised to 0, w2 raised to 0, w2 raised to 1 multiplied by x of 0 and x of 1. So the matrix is 1 1 1 minus 1 into x of 0 x of 1. So this is regarding 2-point DFT. Now we'll move towards 4-point DFT. 4-point DFT. So here we will put n is equal to 4 in the equation, so that x of 0, x of 1, x of 2 and x of 3. So put that values into the equation of value k. If you put the k value, this becomes 0, 1, 2 and 3. Now summation will start from 0 to 3, 0 to 3 x of n. So this equation, it is simplified. After simplification and putting the values, you have to expand this. Expansion will be x of 0 is equal to x of 0 w4 raised to 0 plus x of 1 w4 raised to 0. Then put, this is the expansion of all the values. So you can have that into matrix as we have written the matrix for 2 by 2. So this is nothing but the matrix for 2 by 2. So here we can write the matrix for 4 by 4, that is w4 is to 0. So first value, if you see x of 0 is nothing but multiplication of this multiplied by x of 0, this is multiplied by x of 1, this is multiplied by x of 2, x of 3. So we have written that in w4 is to 0 0. So all the values are written in the matrix. Now find out the values, each value of w. So w4 is to 0, I will calculate it. If suppose w4 raised to 0, it means e raised to minus j 2 pi, nk value is 0 divided by 4, so it is e raised to 0 1. If you calculate w4 raised to 1, so it is nothing but e raised to minus j 2 pi 1 divided by 4, so it is e raised to minus j pi by 2. So it is equal to minus w4 raised to 1 e raised to j, means it is cos of pi by 2 minus j sin of pi by 2. Cos pi by 2 is 0, sin pi by 2 is 1, so it is equal to minus j. So similarly we can calculate all the values, and simply we can remember with this division of quadrants a whole into 4, that is w4 raised to 0, it is w4 raised to 1, it is w4 raised to 2, this is w4 raised to 3. So this axis, it is 1, this is minus j, this is minus 1 and this is j. So w4 raised to 0 is 1, w4 raised to 1 is minus j, this is minus 1 and this is j, and then it is recursive. This is w4 raised to 4, it is w4 raised to 5, w4 raised to 6, w4 raised to 7, then w4 raised to 8, w4 raised to 9 and so on. So by using that we will have all the values, and finally we can write the matrix as this is the 4-point DFT matrix: 1 1 1 1, 1 minus j minus 1 j, 1 minus 1 1 minus 1, 1 j minus 1 minus j. So once we have this matrix, so we can calculate 4-point DFT using that matrix. So this matrix is important, you have to remember this matrix, So the values are 1 1 1 1, first row is 1, then 1 minus j minus 1 j, 1 minus 1 1 minus 1 1 j minus 1 minus j. So we'll solve problem on it.